Hello, this video was produced by Forge College. You've just finished your capstone smart contract, which means you have a contract that actually does something. That is a huge milestone. But now that your code is changing state safely inside its locked vault, we have a practical challenge. How do external applications, like a mobile wallet or a block explorer, know when those changes actually happen? Many developers start by trying to write every single notification or audit trail directly into the contract's permanent memory. It's like trying to record every single conversation you have in a granite monument. The flaw here is the cost. Writing to that permanent storage is expensive. Using it as a simple notification board is a quick way to drain your gas budget on fees that provide very little actual value to the contract's logic. Smart contracts need a way to announce state changes to the rest of the world, but they need to do it without paying that massive premium for permanent on-chain storage. The solution is the Solidity event. While storage is like that heavy, expensive ledger, an event is like a megaphone for the contract. When your contract emits an event, it creates a log stapled to the transaction receipt and sent to the network, bypassing internal storage slots. Producing these temporary logs is significantly cheaper than writing the same data into the contract's internal variables. To keep the terms straight, the event is the structure you defined in your code, while the log is the actual record generated on the blockchain when the code runs. Events are the gas-efficient mechanism for broadcasting information to external systems that live outside the blockchain. But if thousands of contracts are using these megaphones at once, how does a wallet find the specific message meant for one specific user? We use indexed parameters as specific filterable keys attached to the log. The EVM takes these parameters and stores them in standardized slots known as topics. Any remaining unindexed data gets grouped into the log's general data payload, kept completely separate. Off-chain applications use these topics to instantly fill for the exact events they need. It's the difference between scanning a giant library for one word and just looking up a specific ID in an index. Without these indexed search keys, the stream of blockchain logs would be a wall of noise, nearly impossible for external apps to use effectively. There is one specific limitation you have to keep in mind. This communication channel only flows in one direction. Once a contract broadcasts an event, it cannot hear its own message. A smart contract has no way to read its own past logs while it is waiting. These logs live in transaction receipts, safely tucked away outside the contract's accessible state memory. Because the contract itself is blind to them, logs can never replace storage for data that the contract needs to check or use for its own internal logic later on. This leads to the most important architectural choice you'll make, deciding when to use storage and when to use logs. Here is the breakdown. Use on-chain storage for data the contract must read and enforce, like account balances. It's expensive, but the only way the contract sees data. For everything else, transfer alerts, notifications, audit trails, use events. This keeps costs low while informing external apps. In our next lesson, Event Syntax and Declaration, we will move from the theory to the keyboard and learn the exact code to build these event interfaces. This video was produced by Forge College. Visit forge.college to learn more about this subject and other Web3 related topics. See you next time.